Now just think about it. With just 4 lines of code, we took the raw data, we filtered it, we grouped the filtered data, summarized and got whatever we want, and then arranged it to look exactly to what we had in the match summary. This is so beautiful and this is so easy. Hello everyone, Shrey here. So in today's video, we'll do a complete walkthrough on how to generate the match summary that we see at the end of every IPL game from scratch, from raw data. So we'll be looking at this 2023 CSK versus Rajasthan Royals game where Dhoni almost won the game for CSK. So this match is very dear to my heart. So without wasting any other time, let's get started. So we have the raw data over here with us, which is a CSV version of the CSK versus RR game, which happened on 12th of April 2023. This is a clean file that I have over here. So if you guys are interested on learning on how to get the raw data from the web and clean it and prepare it for data analysis, I have a separate video for that. I'll add the link below in the description. So looking at the data over here, let's just first see what do we have. So we have the type as ball over here. It doesn't really matter, but let's go over the other columns. We have the innings, the first and the second innings. We have over and ball. So over is like starting from 0 because always it starts from like 0.1, 0.2 over and then on and then so on. Ball is again ball number 1, 2, 3, 4. We have the batting team, which is like Rajasthan Royals batted the first innings. So we have their name over here. We have the batsman, Yashasvi Jaiswal, Joss Butler as on the non-striker. We have the bowler, and this column is the runs off the bat. So whatever the batsman scores and is counted towards his quota is over here. We also see if there are any extras, any wides, no balls. So if there are no wides, then it is NA. And if there are wides, then accordingly we'll see in the later video on how to deal with wides and stuff. So we have wides, no balls, buys, leg buys, and sort of penalty if we have any. Also we have the kind of wicket. So if a batsman got out, so what kind of wicket is it? So it's a caught over here. And who is the batsman who got out is the dismissed player column over here. There is this column called is wicket. That means that whatever row we are selecting, does that row indicate that it is a wicket? So in this row, there is a wicket, so this column has 1 in it, and otherwise everything else is NA. And we also have this one last column called total runs. So this is the runs scored off the bat plus the extras plus whatever things. So the total runs that were attributed to the batting team. Our aim for this video would be to take this data and produce sort of something which is like this. By the match summary, I mean just the values over here, like what was the total number of wickets for Rajasthan Royals and like what batter scored how many runs and how many balls, just the match summary. We're not talking about the visuals because that's a completely different aspect for any other video. We're just talking about how can we gather the data that we have in a very normal CSV and how to just generate the values that we see in the match summary. So let's get started. We'll just shoot up our R Studio. I have a template already with me with the steps and instructions to make it very clear for you guys. So if you don't have R Studio installed, I'll add the link to the description of my video where I talk about the installation of R Studio online, and it's a complete walkthrough. It's a very short video, so it will be helpful for you. But nonetheless, I'll just walk through the first 3 steps to get started with it. So if you have R Studio, the first step is to navigate to the folder. So just add this CSV file. Also I'll just mention that I'll add the link to the CSV file download also in the description below. So create a folder with the CSV file and just click these 3 buttons, like 3 dots over here, and navigate to the folder that you have. And once you navigate to the folder, click open. Then you'll see the files in that folder. So it should have the CSV file. The next step would be to set that folder as the working directory. It will help you to read that CSV from the script that we'll be writing. So to do that, just click more over here and set as working directly. Directory. Yeah, sorry, it's like I'm just covering it right now, but I have this explained in my R Studio setup, so that should not be a problem. We'll be using only one package in this tutorial. It's the Tidyverse package. So to load the Tidyverse package, we just write library Tidyverse, and as soon as we run it on the console, we can see that all these packages are loaded, which are a part of Tidyverse. And so let's just read this file using the Tidyverse read_csv into the data frame called raw. Now I use Tidyverse like this, as in I just write the file name and then pipe to read CSV. This is called a pipe symbol. To get it, you can do a shortcut of Control Shift and M on a Windows and Command Shift and M on a Mac. So this just means take whatever is on the left and do this. So take this and do that basically. So if I have, let's say, a bunch of numbers from 1 to 10, like I have 1 to 10 and I want a sum of this, so I can take 1 to 10 and then pipe to sum. So if I just run this, I'll have a sum of 55. The other way without using the pipes would be sum of 1 to 10. It's like as simple as that. So if I run this again, it's 55. So I like to just keep it straightforward, and you'll know why I do and read stuff in this way. So without spending more time on this, I just take this CSV over here and read it. For again reading, I just press Command and Enter on Mac and Control and Enter on a Windows. So as soon as I do that, I have this raw data over here in my environment. I can just click over here and open it to view. This should look exactly like the Excel that I showed you before in the video. So again, we have this data set now loaded into our environment. So the first thing would be just looking at some exploratory things, as in just checking, just like doing a sanity check on whatever we have read in is correct or not. So we have the raw data. To access a particular column, we just use the $sign. So if I just write raw and put a $sign, I can access all the columns as a single piece of vector. So if I do batting team, for example, raw $batting team will give me that batting team's entire column. If I press enter, all I would have is Rajasthan Royals, because this data contains Rajasthan Royals all the way down. So it's just fetching that one column for me. And if I take this entire, if I take all these values and I want to find the unique values, I can just pipe it to unique. So as soon as I do that, I know that there are two teams who played this match, that is Rajasthan Royals and Chennai Super Kings. So that's what that's what this $sign and the unique function do. And similarly, if I want to check what are the batsmen who played in this game, I can just do a raw $batsman. This will give me a long list of the entire column, and just by doing a unique on it, I can actually just see which particular batsman played. So there were about 17 batsmen who played this game. Now, when we look at this data frame, we see that it was Rajasthan Royals who batted first. And talking about the summary, if we want to generate this summary, we will start with generating the details, as in this total, the number of wickets, the batsman statistics and the bowler statistics based on when Rajasthan was playing. So if I just move this side for a bit, what I can do is I can only filter my data frame to contain the Rajasthan Royals portion. So the way that I do that is I just take the raw data, pipe it to filter where batting team is Rajasthan Royals, and I save it to a new variable called RR, or a data frame called RR. If I run this, you see over here I'll have 126 observations. That is the Rajasthan Royals roughly played 126 balls, and everything that is in here is the data when Rajasthan Royals were playing, and it will have no CSK as the batting team in the column over here. And just to make sure, we can again check RR batting team unique. It's only Rajasthan Royals, so we have filtered it out correctly. Now just to calculate the total number of wickets, like when we are starting off with the summary over here, we'll calculate the total number of wickets, that is it should be 8 wickets, total number of runs, that is 175 runs, and then we'll calculate the runs scored by the top batsman and the wickets taken by the top bowlers from the Chennai side. So we are only focusing on Rajasthan Royals first. So now calculating the total wickets, what we have over here is an is wicket column. So we can just do a sum of whether that particular row in our data is a wicket or not, and we would get our answer, right? So if we do a sum of Rajasthan Royals dot is wicket, or like just to be consistent, I'll do RR is wicket pipe to sum. So it gives me an NA. So why is that? So probably going back to the column, like this will help. It's giving me NA because this is wicket column has all of NA values over here, and the property of the sum function is that if any value in a sum is NA, it will make it NA for the entire thing. So let's say if I have sum of like 1, 2, 3, 4 and NA. If I do this, I'll get NA as the sum. So just to remove it, as in just to make sure that we do not count the NA, I can add an attribute called NA.remove is equal to true. And as soon as I do that, I get the sum without considering the NA. So straightforward, back to the is wicket part. If we take the entire wicket column and while doing the sum, we remove the NA, we'll get 8 wickets fell in the Rajasthan's innings. Let's check if if it matches. Yes, we have 8 wickets. So that's good. The next would be the total number of runs. And we have the column again, total runs in our data frame. So we just need to do a sum of the total runs that was scored. So remember the total runs contains everything which is runs off the bat and the extras. So we do a sum RR total runs and NA.remove is equal to true. Make sure that you do not get confused between this kind of a syntax and this kind of a syntax. It is the same thing. So yeah, if we just run this line, we get the sum as 175. Now just cross checking. Yes, we have 175 as the total and the number of wickets as 8. So that's solved already. So now that we're done with having the total and the number of wickets, we'll move on to the batsman, where we'll be calculating the runs scored by each batsman. But before that, I'll have to cover a very important topic, which is called group by and summarize. So keeping this on the side again. Now what is group by and summarize? Without giving any definitions, I'll just show you how this works. Let's say we have a data frame which looks like this. It has 2 columns. The first column is called first and the second column is called second, just to keep it very simple. The first column has 3 unique values, that is AA, BB and C. And they have some corresponding values as 1, 2, 2, 2 and 5. The goal for us is to calculate the sum of the unique values that we have in the first column. So the way that we'll do is we'll group our data by the first column and then do any operation that we need to perform in the summarize function. So doing things line by line, let's say I first run it only till here. This is the data frame that we're looking at. I group it by the first column. Now as soon as I run this, just look at what we have over here. We have first and second displayed over here. Now when I run this line, it'll also show a new line defining the number of groups that we have. So if I run this, yeah, we can see we again have like 5 rows, 2 columns, but now it also has groups, which indicates that it's grouped by the first column, and the first column has 3 groups inside it. the data frame is the same right now because we haven't done anything. We have just grouped it. And now after this line, group by, whatever we do will happen on a grouped basis. It will not happen on a line by line basis. Everything, like if we do a sum, if we do a count, if we do anything, it will take this as like one group and then perform the operation. So our first group is this, the second group is this, and the third group is this. What I want to do is just calculate the total of the sum of each group. So I'll write summarize. This is the name of the column that I want. And what do I want the sum of? I want the sum of the second column over here. So just by looking at it, we should first guess what the output should be. You can like pause the video for like 5 seconds and just guess what the group by and summarize should look like. So when we do this, we should have an output of 3 rows containing the unique groups, that is A, B, and C, and the sum of the second column. That is, A should have the value 3, B should have the value 4, and C should have the value 5. So if I run this, I have the column first, which are the groups. A has the value of 3, B has a value of 4, and C has a value of 5. Now this group by and summarize is so powerful that just by using this, we'll be able to just calculate everything that we see in this over here. Jobs, Butler, particle, whatever. These values that you see will just come by group by and summarize. So let's get on to it. So we take this data frame, RR. If we like run this, we have everything over here. We group it by the batsman. So now what we want is, why are we grouping it by the batsman? We'll just take each batsman and sum the total number of runs that he scored. That's it, as simple as that. So as soon as we group it by the batsman and I run this, it will show that 9 batsmen have played in their innings. Now that we have grouped the Rajasthan Royals data frame with the batsman, we need to summarize the number of runs that they scored. So we just need to do a sum of the total runs that they have scored, as in total runs, as in the runs of their bat. So let's say a batsman hits something and there are extras as well, some overthrows and stuff. So we will not count that because those runs count towards the team's total. And if we check our data frame again, we have runs of the bat, extras, wides, no balls, byes, legs, byes, etc. All these extra runs do not count towards the batsman's total. So we'll only use this runs of the bat column to do a total of the runs scored by a batsman. So if I just do group by batsman, summarize, sum of the runs of the bat, and na.remove is equal to true is just like what we do, and the number of balls that he played is equal to n. So this is a function n which just counts the number of rows. So whatever number of rows that we have in our data frame is the number of balls that the batsman played. So if I just do this right now and run it and bring my math summary back again, just a minute, yeah. So I can see that Butler scored 52 runs. That's correct. Butler scored 52 runs. Particle scored 38. I can see Hetmeyer scored 30. Ashwin scored 30. That's as straightforward as it can be. But over here, they are like displayed in descending order of the runs scored and ascending order of the balls played. So although Hetmeyer and Ashwin scored the similar amount of runs, Hetmeyer scored it in fewer balls, so 18 and 22. So we'll just arrange this data frame first by runs in descending order and then by the balls in ascending order. So moving it at the side again. So I just do a descending order of runs. So yeah, sorry for not explaining. We just use the arrange function to arrange our data frame. So we do the descending order of runs and ascending order of balls. So if I run this, I'll have this exact same thing now again with me. So now Joss Butler 52, 38, 30, 30 and 30, 30. But when I look at this, it's not accurate. The number of balls that I have over here are a bit more than what we actually have in the match summary. So what could be the reason behind it? If you think about it, in our data frame, each row signifies something. Each row is an event in the game. So as soon as I think about the extras over here, if we have, let's say, a column which is wide over here. If we have a column wide and the batsman is Butler, even though there is a row which is being counted under his name that yes, he played that row, all the extras as in wides and no balls, although the batsman is at the crease, that particular ball does not count towards his quota of like scoring runs. So wherever there are like wides and no balls, we need to exclude them to count the number of balls that we have in our group by and summarize. So let's again just go through by filtering the number of wides and the no balls from our data set. So we have this data set again, Rajasthan Royals. We filter the wides and the no balls. Wherever the wides and no balls are NAs. Now explaining this one, we only want the rows where we have NAs in the wides and the no balls. Wherever we have any value in the wides, that means it will not be counted towards the batsman's quota. So we only want the values which have NAs in them. So we are filtering by we want NA and we want NA in the no ball as well. So if I take this data frame, filter it by wides and no balls. If I just run this first, I have 126 rows, but when I filter it for containing no wides and no balls, I have 120 rows. So that means there were 6 wides or no balls associated. Now I'll just keep everything the same. If you look at this and if you look at this, it is the exact same thing. It's just that we have added one filtering line over here. And if I run this, and if I now check the match summary, we have the exact same thing now. Joss Butler scoring 52 of 36 balls, Particle scoring 38 of 26, Hetmeyer scoring 30 of 18, and Ashwin scoring 30 of 22. Now just think about it. With just 4 lines of code, we took the raw data, we filtered it, we grouped the filtered data, summarized and got whatever we want, and then arranged it to look exactly to what we had in the match summary. This is so beautiful and this is so easy. So now that we're done with the batsmen, let's focus on the bowlers to generate the number of wickets and the runs they conceded over the course of the match. So again, we just do a group by and summarize. We take RR, we group it by the bowler, and now the runs that we calculate, like the sum of the runs, will be the total runs. It will not be the runs that are scored by just off the bat, because even extras or leg byes or everything counts towards the bowler's quota. So we just group by every bowler that we have, and we do runs is equal to sum of the total runs, NA dot remove, and the wicket is the sum of the is wicket column over here. So if we have a wicket, then the value is 1. So we'll just do a sum of the number of wickets that were taken. And so I'll just first run this. So we have the bowler, we have the runs, and we have the wicket. But turns out that when we look at the match summary, we first have the bowler, we have the wicket first, and then the runs. So we just do a simple select statement. It's used for selecting the columns we want, and we can also use it for rearranging our columns. So if we specify bowler, wickets, and runs, this is how our final data frame will appear. So these values will not change. It will just rearrange within the columns. So if I just run this, I have Akash Singh taking 2 wickets for 40 runs, and I have this as the complete format. And the way this is arranged is we first have the arrangement by the number of wickets, and by the ascending order of the runs scored. So if I do this, I have that Tushar Deshpande took 3 wickets and 37 runs, and let's just probably compare it to what we have over here. Okay, so this says something different. It says Jadeja should be on the top with 2 wickets and 21 runs. Deshpande should have 2 wickets and 37 runs. So okay, the runs are correct. Then it should be Akash Singh, okay, 2 wickets for 40 runs, and then Moeen Ali for like 1 wicket and 21 runs. So our values are correct. It's just that for Deshpande, it says that it has 3 wickets. So let's just probably look at what did Tushar Deshpande do. So if we just take the data set and filter the like the bowler with Tushar Deshpande and view it. So just another shortcut. If we just pipe it to view, it will open as a viewer over here. We can always save this as, let's say, as a new data frame and then view it from over here. So it just saves like a couple of seconds. So when we look at his wickets, let's just go to the kind of wicket and his wicket. So we have caught, okay. We have again caught, okay, and we have a run out. Okay, so because Tushar Deshpande was bowling, in the bowler column, it's his name. But because the kind of wicket is run out, it's being calculated towards his quota when the runouts are calculated in the team's quota. So clearly we need to do what? We need to filter out for this row where the kind of wicket is run out. And I think that should solve the problems. So filtering the points where the kind of wicket is not equal to run out, we take the same thing again. We take the Rajasthan Royals dataset, we group it by the bowler, we summarize by the runs is the sum of the total runs, and the wicket is the sum where kind of wicket is not equal to run out. So I'll just do the same thing again, rearranging by bowler wicket runs and arranging by the most wickets first and then the ascending order of runs. You see this negative sign over here? It's like a shorthand for writing descending. So if I write descending over here, or if I just put a minus sign in front of wicket, it does the same thing. So now when I just run this, it now has Jadeja on top. I think this is working. Let's just compare quickly. It has Jadeja 2 wickets 21 runs, Deshpande 2 wickets 37 runs, Akash Singh 2 wickets 40, and Moeen Ali 1 wicket and 21 runs, and we are done with it. We are done with the first section of our match summary. And the next step is to make it for Chennai Super Kings. And the beauty of this code is that we haven't done anything which is hard-coded. So if we just copy whatever we have done for the Rajasthan Royals team and paste it for Chennai Super Kings, we should have the results like right there itself. So let's do it. So for Chennai, we take the raw data, and again, like we filter the batting team by Chennai Super Kings. So right now on the right side, we have the raw data, we have the Rajasthan Royals data frame and Tushar Deshpande's specific outlier case. So as I run this, I'll have CSK over here. So this will contain everything as the batting team as CSK. I'll do a total wickets, that is sum of the is wicket column. Let's see how many wickets, 6 wickets, and the total runs of the bat and the extras as in all, or the total runs would be 172. Quickly tallying it by the match summary. Yes, CSK scored 172 for 6 runs. Now moving on to the Chennai Super Kings batsmen, we do the exact same thing. Just CSK filter by the wides and no balls, group by the batsmen, summarize by the number of runs, arrange it by the number of runs and also the balls scored. So number of runs as in the descending order of number of runs. So if I do this and if I just check it once, perfect. Devon Conway 50 runs, 38 balls. Dhoni, 32 runs, 17 balls, 31 runs Rahane, 19 balls, and 25 of 15 for Jadeja. As simple as that. So we are just reusing the code. And similarly, we'll do it for the bowling. where we are grouping by the bowler, summarizing the total runs, not the runs of the bat, and summarizing where the kind of wicket is not run out, and just arranging by the maximum wickets and the lowest runs conceded. And if I run this, I'll have Ashwin with 2 wickets, 25 runs, Chahal with 2 wickets, 27, Sandeep Sharma with 1 wicket, giving out 30 runs, and Adam Zampa as the impact player with 1 wicket and 43 runs. So with just that, we finished the entire match summary, taking into consideration everything from total runs to wickets, wides, no balls, batsmen, bowlers, with the edge cases as well. I know that there are a lot of other edge cases that we might need to consider, but for this particular match, it works. And just by writing plain reproducible code without any hard coding values and using the pipeline method of programming, where we just take our data frame and keep on applying different functions to it, it just became so easy, and we never used more than 4 or 5 lines of code to achieve what we wanted to achieve. And yeah, I hope you liked it, and see you in the next video. Bye bye.